How's it going, everyone? In this video, we'll be talking about matrix addition and multiplication by a scalar. And we'll be talking about not augmented matrices. Okay, so an augmented matrix is something that would look like this, where you have this last column right here. If this is a system of equations, that last column would be representing numbers that are not multiplying any variables, for example. That's an augmented matrix. A not augmented matrix doesn't have that last column. Okay, it just has these values right here. A lot of the time, that's all you look at. Matrices to find out, for example, their rank, to find out what they look like in row echelon form. You only need that part of the matrix. The final column in the augmented matrix doesn't make a difference. And there's many other reasons why a matrix as a mathematical object is useful as it is in its not augmented form. So that's what we'll be looking at when discussing matrix addition and multiplication by a scalar. First thing we're going to do is we're going to come up with labels for the entries in a matrix. Okay, so let's say you have matrix A and it has m rows and n columns. Okay, so there's matrix A, right? And the number of rows is m. Okay, so we can call it an m by n matrix. M by n matrix. And that is a common way to refer to matrices. You say the number of rows first and the number of columns second. Okay, so how many rows do we have? Okay, so that first row, okay, the very top entry will be A1 because it's in the first row, and another 1 because it's in the first column. Okay, that second entry, it's still in the first, it's in the second row, but it's still in the first column. Third entry, it's now in the third row, but it's still in the first column, and so on. And finally, the very last entry in that first column is the mth row, because there's m rows in total, and we're still in the first column, right? What about the first row, second column? Well, A first row, second column. Next one, A first row, third column, and so on. And eventually the very last entry in that top row will be the first row, nth column, because there's n columns in general, right? What about this value here? Well, that's the second row, second column. What about this value here? Well, that's the second row, third column, and so on. And the very bottom entry, okay, the bottom row, the very last column, that'll be the mth row and the nth column. So every entry in a matrix has this kind of label, and that will become very useful when we're defining what matrix addition is, multiplication by a scalar as well. So if we say, for example, let's say our matrix A equals 3, 1, 2, negative 7. Okay, well then A11 equals 3. A second row, first column, what's that? Okay, well the second row is right here, the first column is right here, so we're talking about the 2. Okay, that's the labels we're going to use. So the first thing we'll do is matrix addition. Okay, so let's say you have matrix A, which equals A11, A12, and so on, up to A1n, because that's how many columns you have. And here you have A second row, first column, and so on up to AM1. And then you have A m rows and columns right there. And let's say you have matrix B, which is also m by n, right? So that's going to be a B11, B12, and so on up to B1n. This is going to be a B21, and so on up to M1, and the very last entry is B, M, N. Okay, so A and B are both M by N matrices. They have the same dimension, okay, and we need that, the same dimensions. We need that to add them, because when you're adding them, A plus B, you're just going to add the corresponding entries. All right, so what that's going to look like is you're going to have A11 plus B11, then you're going to have A first row second column plus B first row second column, then A first row third column plus B first row third column, and so on up to A first row last column plus B first row last column. And same with every other entry, okay? A second row first column plus B second row first column, and so on, right? Adding up all the corresponding entries, just as if you're placing one matrix on top of the other, and whatever components line up. Oh, sorry, that should be mth row first column, right? Whatever components line up, that's what you add. Okay, so for example, let's say you have 1, 3, -2, 5, plus 1, -7, 3, 2. Okay, so you just add the corresponding components. This is going to be 1 plus 1. This will be 3 minus 7, or 3 plus -7, -2 plus 3, and 5 plus 2. Right? So that comes to 2, -4, 1, and 7. And you don't have to work with a square matrix necessarily, okay? As long as the dimensions are the same. So we could have, say, 2, 3, -1, 1, 0, 2. And we add that to the matrix 1, -1, 0, 2, 1, 2. Okay, so what do we get? So here is going to be 2 plus 1, that's a 3. 3 minus 1 is 2. -1 plus 0 is -1. 1 plus 2 is 3. 0 plus 1 is 1. And 2 plus 2 is 4. And that's matrix addition. Okay? Matrix subtraction works the same way, except you are subtracting the components, right? So let's say you have 3, 2, 1, -1, 2, 4, and you're subtracting the matrix 3, 0, 1, 5, -1, 7. Okay, so you're going to have 3 minus 3, which is 0, 2 minus 0, 2, 1 minus 1, that's another 0, -1 minus 5, -6, 2 minus -1, that's 2 plus 1, so that's 3, and 4 minus 7, that's going to give you -3. And that's it. That's matrix addition, matrix subtraction. Okay, now what if you're multiplying by a scalar? Okay, let's say you have some scalar c times a. Well, what is that? That's just a plus a plus a whole bunch of times. How many times? C times. Okay, what the result is going to be is every single entry into A is going to be added up C times. In other words, you're multiplying every entry of A C times. Okay, that's what that is by definition. Okay, so that is going to be C times A11, C times A first row second column, C times A first row third column, and so on up to C times A first row nth column. Okay, and it's like that for every entry, right? Second row first column, third row first column, A nth row, or sorry, mth row first column, and so on, including that bottom right entry, C times A, mth row, nth column. All right, so for example, let's say you have 3 times A, where A is equal to 1, -2, 3, 5, and then 3 times A is going to be equal to 3 times 1, which is 3, 3 times -2, which is -6, 3 times 3, which is 9, and 3 times 5, which is 15. So scalar multiplied by matrix, you're just adding that matrix a bunch of times. And because it's just a string of addition, you have properties like this, where one scalar times some matrix, okay, plus the same scalar times another matrix. Well, you can factor it out, and it will be like that scalar multiplied by one matrix plus the other. Okay. Also, as with addition, you can add matrices in any order and get the same result. Okay. So that is matrix addition and multiplication by a scalar. In a different video, we'll talk about multiplication of a matrix by another matrix. So I'll see you then.